When designing an experiment, what exactly is our purpose? We are trying to determine if a specific variable will have an effect on a certain outcome. So how can we be sure that it is our desired variable affecting the outcome and not something else? This is why controlling variables in an experiment is so important. We have to make sure that we take as many other variables into account as possible. For example, if we wanted to test the effect of chlorine on pool water pH, why would it not be a good idea to test samples of pool water from different local pools? Let's think about other variables that might affect pH other than chlorine. Outdoor pools might be exposed to rainwater or other forms of natural moisture that indoor pools are not. Outdoor pools would also have higher traces of sunscreen. Pools which are more frequented by children might have more urine in them. All of these variables could change the pH and give us false results. So how can we make sure these variables do not skew our results? The easiest way would be to make sure our samples are as similar as possible is by controlling variables. So instead of taking 10 samples from 10 different pools, maybe we could use 100 samples from one pool. This way, even though natural moisture, sunscreen, and urine levels might be present, they will be pretty much the same over all the samples. Thus, any change we see in pH would not have been brought on by those other factors. Another way to account for other variables would be to include a negative control group. A negative control group is a trial that is left unmanipulated. This allows us to see the effects of the background variables, and thus determine if our independent variables actually affected the outcome. Staying with our pool pH example, we could test the pH of a sample of pool water without chlorine, without rain, urine, or sunscreen. This would give us a baseline pH reading to help us determine if chlorine even affected pool pH at all. So when designing an experiment, it's important to account for all variables as possible, through controlling variables or through a negative control group that will allow you to manipulate the specific variable that you want to have an effect on a certain outcome.